In this video, I'm going to show you how to describe a data distribution using shape, center, and spread. At the top, I've listed some words that we will use to describe shape, center, and spread. I'll talk more about what each word means as we use them in each of the dot plots. The first dot plot is representing the height of male and female basketball players in inches. In my previous video, we calculated the mean, median, and mode already, so I have them already written on each dot plot. And if you want to remember how to do that, you can go back and watch that video. I'm actually going to go through each dot plot and describe the shape, then go back to the first one and do the center for each dot plot, and then do the spread for each dot plot. So that'll be the order that I go in. For the first dot plot, we need to first describe the shape. One thing I like to do to help me look at the shape of my dot plot is to draw this curve over top of the dots to give me a summary of the shape. Now, as you can see, the shape that we drew has two peaks and it also looks symmetrical. So because it has two peaks, we're going to call it bimodal. The bi means two for the two peaks, and then the modal part means there's two modes, which is what we had found in the last video, is that this dot plot has two modes at these two peaks. So that's why we call it bimodal, two modes. The other word we want to use to describe this is symmetric. As you can see, if I were to draw a line down the middle, you'll see that the graph looks the same on both sides of that line. Now let's go on to dot plot number 2. We need to describe the shape of this one as well. And again, I like to draw this curve over the top so I can look at the overall shape. Now in this one, I only have one peak or one mode. So I'm going to call this unimodal. And that prefix uni means one. And so that means we have one mode. Now we use the word symmetric in the last example. This one is also symmetric about this center line. It's the same on both sides. It reflects over that line. So it's unimodal and symmetric. Now there's an important word that we use to describe any distribution that is unimodal and symmetric, and that word is normal. So it's very important that you start using this word to describe any distribution that is unimodal and symmetric. So that's going to be the word you see us use more often to describe this shape. You might also see it referred to as a bell curve because it looks like the shape of a bell. But the most important word to describe this distribution would be normal, and that means it's unimodal and symmetric. Going on to dot plot number 3, if I draw the shape, you'll see this is a different shape, and most of the dots are on the left, and then we only have a few dots on the right, and it's creating this tail. We call this a tail because there's just a few dots on the right side that causes the shape to still get dragged out to the right, and it looks like a tail, even though most of the dots are on the left. So because this tail is pulling our distribution to the right, we're going to call it skewed right. That's what we call any distribution like this where we have just a few dots on the right side creating this tail on the right means it's skewed right. So even though there's more dots on the left, the tail, the direction of the tail tells us the direction that it's skewed in. So for dot plot number 4, you will see it has a similar shape, but it's the opposite. Our tail is on the left side, even though most of the dots are on the right. The tail is pulled on the left side, so we call that skewed left. All right, now I'm going to go back to dot plot number 1 and go ahead and find the center for each dot plot. So what we're trying to do is determine the best measure of center. Now at the top, I've listed mean, median, and mode as all possible ways we could describe the center. So since we've already calculated the mean, median, and mode, let's figure out where is the mean, median, and mode on the distribution and which one best describes the center. So as you can see, the mean and the median are both 70.5, which is actually right here where I already drew my center when we were talking about the shape. The mode is 68 and 73, which I already drew as the two peaks. So one of the main reasons we can say the mode is not going to be a good measure of center is because there's two modes. So telling someone these two modes does not help them to understand where the data is centered. The mean and the median, which are the same, both are exactly in the center, so those would be the best measures of center. The mean or the median, they're both 70.5. So sometimes there are more than one measure of center that is good to describe the data, but we know we can't use the mode in this situation. Now in the second dot plot, all of the measures of center are the same, all three. They're all 71 inches right here in the center that we already drew when we were talking about the shape. So since all three of them are at the very center, we can actually use the mean, median, or the mode in this situation because they're all centered at 71 inches. And it's really important that you know whenever you have a normal distribution, so because this is normal, you can use any three of the measures of center to describe it. So anytime you have a normal distribution, you're going to have the mean, median, and mode all in the middle, and they're all going to be fine ways to describe the center. So whenever it's normal, you can use mean, median, or mode to describe the center. Now if we go on to dot plot number 3, let's start by putting the mean, median, and mode on the dot plot so we can see where they're at, because this time they're all different. The mean is at 67.6, so that's around right here. I'll label that as the mean. The mode is at 66.5, so right here. Sorry, the median is at 66.5, so right here. And then the mode is at 66, right here. So as you can see, they're all at different places, and let's talk about why that is. First of all, the mean is the farthest to the right. The reason for that is that the tail being on the right, those few bigger values on the right are pulling the mean the farthest to the right. The median's just about what dot is in the middle. So the median is still pretty well centered. The mode is still all the way on the left because the mode is just where we see the most dots. So again, the mean gets pulled the most in the direction of the tail because when we add up the values of all those dots, the bigger values that are in the tail end up making the mean a lot bigger than the other values. So in order to determine the best measure of center, we want to use the median. The mean is just too far to the right. It's not a good measure of the center of the data. It doesn't look like most of the data because it's farther to the right. The mode also isn't great because it doesn't describe the fact that there is a tail pulling it to the right. The mode makes it look like we can't really tell if there's any big values on the right side. The median is perfect because it's not quite at the peak, but it isn't too far pulled to the right by the tail. So we're going to use the median, which is 66.5 inches. Okay, now for the dot plot number 4, this one's also skewed, and if we put all our mean, median, and mode on, our mean is at 72.5, which is right here. As you can see, it's also pulled very far to the left in the direction of the tail. The median is at 74. And the mode is at 75. So once again, we have the mean being pulled the farthest, most impacted by the tail, the median kind of staying in a good middle spot where it is getting pulled a little bit, but not too much. And then the mode is still at the peak. So again, the median is the best measure of center to use because it's skewed. So an important note is that whenever it's skewed, or whenever the data is skewed, the median is the best measure of center. So anytime you have it either skewed left or skewed right, you should always use the median to describe the center of the data because the mean is too impacted by the tail and the skew. The mode doesn't show the skew happening at all. It's just staying at that peak. So median is always the best. Now let's go ahead and talk about the spread. And the two things we're going to talk about for spread are range and standard deviation. Let's start just with range because we know more about what range means. Range means how far is the minimum and the maximum away from each other. So for the first dot plot, I'm going to take my maximum and subtract the minimum, and that will tell me how many inches are in the range. So my maximum, my biggest dot is at 76 inches, minus my dot all the way on the left is at 65 inches, so my range is 11 inches. For dot plot number 2, my biggest dot is at 77, and my smallest one is over at 65. So my range is 12 inches. So this one has a little more range. On dot plot number 3, the dot all the way on the right is at 75, and the dot all the way on the left is at 65. So I have a range of 10 inches. And for dot plot number 4, my maximum is over at 76, and my minimum is at 66. So my range is once again 10 inches. Now that helps us to see how far the data is spread, but there's something else we use to describe spread, which is standard deviation. Standard deviation is how far on average most of the dots are from the center. So wherever we've decided the center is, we need to think, how far are the dots on average from the center? Are they mostly close to the center, or are they mostly farther away from the center? So let's just compare the standard deviation of the first 2 graphs with the last 2 graphs. So if I look over at these first 2 graphs, you can see that my centers are right here in the middle, and there are a lot of dots going very far away from the center. So these 2 graphs have a bigger standard deviation